In this recording, we're going to learn about geometric series. So as you learned with arithmetic series, a series is simply adding up the terms of a sequence, right? And so geometric series would be adding up all the terms of a sequence that had a common ratio, right? Where we were multiplying to get from term to term. So let's check this out. We have a recursive formula here where we have a first term given, and then we have a rule to get to the next term, a definition. So it's take your previous term times 2. So why don't you list out as many terms as you think you're going to need to list out for what's specified here by this summation. List them all out and find their sum. And play the recording when you're ready. So hopefully you did so. You paused and you worked this out. So we're going to start with 3. Then we're going to add it to the next term, which is 3 times 2, 6, etc. So we keep multiplying by 2. Question is, when do we stop? Remember, that's what tells us when to stop. Add the first 5 terms. So I've got 4 of them. I need 1 more. Now I just need to add those up. Find some way to add those up. Works out to be 93. Okay? So that's what a geometric series is. Adding up the terms of a sequence that has a common ratio, a geometric sequence. There's a formula for this, just like there was with the arithmetic series. It's a little more challenging to discover than just the rainbows that we had with the arithmetic series, but you'll be able to get it through this explanation, so stick with us here. First, as complicated as this looks, let's just understand a little bit about what it is. When we have a geometric sequence, you remember we do a sub 1, that's our first term, times r, our common ratio, n minus 1 amount of times. Okay, so we're going to do that repeatedly till we get to the last term. So the first term is just a sub 1, then we're going to multiply by r once, then twice, then and so on, till we get to the last term. So that's what this is saying. Add up all those terms. So to lead you to the discovery of this formula for the sum of a geometric series, we're first going to multiply all the terms in this series by r. So let's show what that looks like. First term times r. What's the second term times r? Now the second term already has an r, so now it's going to make it r squared, right? And the third term already has an r squared, so now it's cubed. We'll skip a whole bunch of terms because we don't know how many there are. Now this second to last term, well, when I multiply it by r, I'm getting now r to the n minus 1 as opposed to r to the n minus 2 because that's one more factor. And finally, when I multiply the final term by r, I get just r to the n. Those are all those terms. Okay, so part B of this discovery says, okay, take s sub n, which is listed here. Let's just show what that looks like. Okay, and now I'm going to subtract this expression, okay? So I'll write in blue, subtract that whole thing. Alright, so check out how this works out. You might say, that is absurd. I'll never be able to figure out how to do that. That is crazy. Well, turns out, beneath the surface a little bit, when you look at it a little more carefully, there's a lot of opposites, right? So a sub 1 doesn't have anything to go with it. So let's just write that down. That's part of the answer. But a sub 1 times r minus a sub 1 times r, that's opposite. So that adds to 0. This adds to 0. This adds to 0 with its corresponding term, right? They all are going to add to 0. And the only thing that's left is just going to be subtracting a sub 1 times r to the n. So minus a sub 1 times r to the n. So all those other terms add to 0. Write both sides in their factored form. So the left side, I see a common factor of s sub n. I will write that, but factor it out. Factor out s sub n, so that'd be a 1. That'd be a minus r. And on the left side, well, I've got a factored a sub 1, 1 minus r to the n. And then in the final state, it says, okay, find a formula for s sub n. That's going to be pretty easy to get by itself, right? Because it's being multiplied by this factor. So all I need to do is divide both sides by 1 minus r. So our final form is a fraction. It's this, the right side, divided by 1 minus r. Okay. There is another form of this that I'm going to show you and have you write as well, where the a sub 1 is not factored out of the numerator. And actually on your Regents exam, it's given in this form, so may as well be comfortable with this form as well. Basically just distributing it back, basically what I have here in red. So either form there will work. All right, so let's use this to find the sum of a geometric series. Keep my formula visible there so I can access it, right? So we have to get some information. We certainly need to know the first term. We need to know what we're going by. We need to know that r, that common ratio. And we need to know how many terms are involved. Fortunately, this one gives us all that information. Okay, we're looking for a sum of a geometric series. There's 8 terms. Okay, so we know n has got to be 8, right? So let's jot that down. N is 8. And first term is 3. Okay, cool. Write that down. A sub 1 is 3. And I would encourage you to follow this practice, kind of specifying what you know, right? There's a formula involved. Okay, so you look up, okay, I've got a formula for the sum of a geometric series. Write that out. You're going to have a sub 1. And I'm going to use this blue version just because that's the one that's provided on your Regents. Nothing magic about it. It's maybe not the form I would choose to use, but it's the one that you're going to see on that Regents on your formula sheet, so we may as well just use it. All right. Now let's sub in all the information we can. So if I'm looking for the sum of the first 8 terms, got my first term of 3 minus a sub 1 times the, I'm going to put it in parentheses, the ratio, which is 4, raised to the 8th power. I would encourage you always to put it in parentheses, especially if the rate is a negative or a fraction. And then the denominator is 1 minus 4. At this point, let's go right to the calculator. This is all numbers. No one is doing this in his or her head, right? The place I see students get mixed up is if they try to do piece by piece and it somehow gets messed up. So we're simply going to go to our calculator. We're going to make a fraction, and we're going to put that in. So just double check that that squares with what you wrote down in your paper, and then hit enter, and it looks like 65,535, and that turns out that's one of our choices, which is great. Choice 4. All right, so at this point, we have these 2 forms, which we figured out on the other side. Again, this one, you might want to make a little note. This is the one okay, so that's the form that's provided on your Regents reference table. So let's use it. This one says, find the sum of this series. Okay, cool. So let's dive in. We want to know the first term. We want to know r. We want to know what n is, right? Shoot. I got the first term. That's 6, right? I can see they're doubling. I got that. That's 2. But I don't know at what point we get to 768. Could probably find out, right? Just press some buttons on my calculator. But I'm just going to right now say that's unknown. But I do know that the nth term is 768. This will be a good opportunity for us to review how to go about finding that n value. Okay? So we go with our formula for the nth term. Why don't you take a moment, pause this recording, sub in everything you know, see if you can find out what n is. Okay, so hopefully you did that. A sub n is known, so I'm going to put in its value, 768. That's going to be equal to our first term times 2 to the power that we don't know yet, n minus 1. We solve it by dividing by 6. Okay, hopefully you did that much. When I divide both sides by 6, I get 128. A little under 6, I'll just show that work. Divide by 6, divide by 6. 128 equals 2 to the n minus 1. There's about 3 ways you could solve this. You could guess and check. You could get a common base, where we talked about how to do that, right? Get a common base for these. Or I could simply dive in and do logs. Let's do logs. So we have an unknown exponent. Logs are a good tool for solving for an unknown exponent. So let's say log. Better what? Pause this thing. You put it into log form. You know how to do this. Play the recording when you have it in log form. Okay, so log base 2 of 128 equals the exponent, n minus 1. Well, it turns out log base 2 of 128 is a 7, which means n is 8. Nice. Now I can solve for the sum. So s sub 8 equals, why don't you sub in all the information you have, use your calculator, and find out what that sum is. Alright, so I'm hoping you did that. At this point, I've got my a sub 1 minus my a sub 1 times my rate to the nth power all over 1 minus the rate. Put all that into your calculator, and we have 1,530. Okay. Our final answer, our final question, I want you to work out and play this recording when you've got exercise 6 all worked out. We're going to skip exercise 5. We'll attack that one in class. Okay, so I'm hoping you worked out exercise 6. Do not cheat and look at this video unless you've worked it out. Okay, I'll work it out quickly because I think this information is pretty clear. We've got our first term, a penny. We're going up, doubling, right? 1 pennies, 2 pennies, etc. How many times? 31 times, right? Now just sub in all the information. So I got a 31. And so yes, she will be, or he will be, a millionaire. Thanks for watching.